My name's Eoin Wickens. I'm the Director of Threat Intelligence at HiddenLayer, and I just want to start off by saying that was an incredible panel. It couldn't really tee up what I'm talking about any better. I want you to keep these three things in mind: insider risk, path of least resistance, and that data security and data governance is key. Clicker. So who I am, not super important. I've been in this space the last few years. I'm going to be talking to you about navigating the AI threat landscape. And basically, a couple months ago, we released our second edition of our AI threat landscape report as part of HiddenLayer. We wanted to create a field guide for understanding the AI threat landscape. As many of keeping up with the latest in advances of AI systems is almost a full-time job. Keeping up with AI security is a second full-time job. And trust me, that's what I do for a living. So what's new in enterprise AI? We have crazy advances coming out. We have multimodal reasoning capabilities where models can interpret video, audio, and text all in the one go and edit things on the fly. We're seeing revolutions in the way that AI models are developed, such as DeepSeek, which almost undermines the economy when such advances are made. We're seeing Salesforce bet big on things like Agentforce, where they're now talking about this as a digital labor platform. The age of digital employees is here, especially when we consider the context of agentic solutions. We're seeing AI models be incorporated into robotics, leading advances within companies like Tesla and Figure. We're seeing RAG systems enabling you to incorporate enterprise data into your models at scale. And these advances aren't stopping anytime soon. So on Hugging Face, which is like the GitHub of machine learning models, last year there was 640,000. This year, 1 million has been added to that platform. Open source AI usage is proliferating at an exponential rate. It's mirroring its enterprise counterparts. And this is great. This is fantastic. It means that we're developing, it means that we're innovating, it means that we're sharing the technology, but there are risks. We surveyed 250 business leaders at the start of this year, and we asked them some important questions. We found that 89% of business leaders are using AI in critical business deployments within their organizations. We found that 74% of them had said that they had actually seen and observed an AI-specific attack in their organization. We saw that 95% of these had allocated budget for securing AI, and 99% considered it high priority. I know I do. So our report is broken down into 4 parts. We wanted to cover as much of the landscape as we could. This was put together by our fantastic research team, which is almost 20 strong, multidisciplinary team of experts across digital forensics, incident response, reverse engineering, threat intelligence, and traditional AI security. We have 4 parts: the risks related to the use of AI, the risks faced by AI systems, advancements in the latest and greatest in terms of securing these systems, and then some predictions and recommendations for the future. So in today's age, AI is being used everywhere. It's being used for phishing now to generate your spam campaigns. It's being used to proliferate fraud at a scale we haven't seen before by creating fake know your customer verification. We've seen banks scammed out of multiple tens of millions of dollars by impersonating executives. And this is growing. We see it in almost polymorphic malware. We see unintended usage of AI leading to data privacy issues, where shadow AI proliferates within organizations. If you block it, it's so performant and it's such a productivity boost, your employees are going to use it anyway. Maybe without the data access controls or data governance policy that you wish you had. We've seen some pretty awful results when people get emotionally attached to AI systems, and even difficulties in determining truth, fact, or fiction, to quote Jonathan Frakes, in the political landscape. But what I really want to talk to you about is the risks faced by AI systems. How can we attack AI systems? How are they vulnerable? And I guess it's worth saying that the landscape really started off in academia. We had focused predominantly on 3 main categories of attack. Data poisoning, where we poison the training data that goes into a model. If you shift far enough left, everything that's right of that will end up being compromised. We talked a lot about model evasion, where we bypass classification models. Think of this like bypassing a malware classifier, or phishing classifiers, or fraud classifiers, or any functionality of that model. And if I told you that we could actually steal models without ever having to access that environment, would you believe me? We can recreate really accurate copies of models for as little as $60 if we have inference access to it. And academia really paved the way for industry to take this and jump. One of the things that's near and dear to my heart is the supply chain. I inadvertently found myself writing about this a few years ago, and it's now become one of the bigger talking points. But again, data poisoning is another key risk. It's transferred from academia. Why? Because there are four main components of an AI supply chain. The data that goes into a model, the models themselves, which are disseminated, incorporated into applications, sent up to websites like Hugging Face and shared. We see infrastructure being used to deploy this at huge scales, like massive GPU farms like the Stargate project recently announced. And ultimately, there's different types of vulnerabilities introduced at every part of this life cycle. With data poisoning, if we control the data, we control the model. If images or other data sets are hosted on websites and they expire, we can buy up those domains and poison that data set. Data sets aren't just one singular artifact. They're often loaded at runtime. Models today, as we saw on Hugging Face, are shared all the time. 1.6 million models today, flying around the place. But what if I told you that models use insecure file formats to serialize them to disk? There's over 20 of them. We found vulnerabilities in probably 10 to 15 libraries that enable us to literally execute code in the environment. We found people exploiting this in the wild, installing Cobalt Strike beacons, installing interpreter payloads, lots of reverse shells, and even leveraging interesting things like steganography to hide payloads. And we've seen abuses in MLOps tooling, which handle the deployment, the maintenance, and the monitoring of ML systems. What if I told you that a lot of these MLOps tools were developed in academia, or developed largely by people who didn't have robust security practices? What if I told you that some of these tools don't have basic things like authentication? Shock. What if I told you that these things were vulnerable to application security vulnerabilities from the last 20 years that we nearly thought we'd stamped out? CSRF, SSRF, overflows, sending empty tasks to servers that execute, again, code. And when you think about the access to graphics cards and access to sensitive information and access to the data that comprises these models, it proposes an incredibly dangerous risk. Last year, we spoke a lot about this same risk, serialization attacks on machine learning models. But we found even more surreptitious ways to embed malware, and I say malware lightly, embed our own attacks into ML models. We can hijack the control flow of a model, the architectural graph, which determines how data moves through this model to produce its outcome, to install a backdoor. Not a backdoor that we can log in on, but a backdoor that if we put in something like a Konami code, a skeleton key, or maybe it's a red pixel in a photograph, we can completely change the output of the model. This means that if I went up to a facial recognition model with a particular pendant, it may see me as somebody else. If it's a mortgage loan approval model and I put in a particular name or postcode, perhaps it gives me the loan. If it was troop movement on the ground, and we said, hey, there's a red car next to these troops, ignore it. We can do that now. And scanning for these threats is incredibly difficult. And as we proliferate AI, we need to be sure that the models are what we get. But they are inherently opaque systems. We can't understand the data that made the model once we have it. We can, most of the time, find it quite difficult to understand how a model comes to a particular decision. So we need to actually create new mechanisms for us to be able to detect attacks like this. So last year, again, prompt injection was all the rage. We spoke a lot about getting a chatbot to ignore all previous instructions and insult me in a chat window. And it's great. Maybe not the insults part. But what if I told you that prompt injection by itself is largely a storm in a teacup? What the real risk is prompt injection in a system. Prompt injection in a system that may have the ability to read documents, to read emails, to browse the web. Any piece of data can compromise the control flow of a model. What do I mean by that? The data and control plane are distinct and separate in most software programming paradigms. However, LLMs inherently can't tell the difference, which means any single piece of data can completely compromise an LLM's decision-making. Again, when we think of this in the context of a chatbot, who cares if it insults me? I've got somewhat of thick skin. But when an LLM is being used as the core reasoning capability for an agentic solution, for issuing calls to APIs, for using tools, for querying databases, for inserting data into databases, and becoming so performant that we're now considering replacing parts of the workforce with digital employees, as we saw earlier, one piece of data that's maligned can now compromise that system and get it to perform any action. We've shown this with Google Gemini. We were able to send an email to Gmail and prompt inject Gemini in the workspace and suggest spam links. We were able to show this with Anthropic's computer use, where it basically interprets the desktop and uses it as a human would with a PDF. We put in some white text, so it was hidden from the background, made it really small, classic college trick, and all of a sudden, it wipes the file system. And these aren't even full-fledged agentic systems. But we're able to do these things today. So, insider threats. Employees today can access sensitive information. They interact with APIs and tools in your environment. They understand where your organization is strong and weak, because we're all not perfect. And they perform actions that affect business outcomes, at least you would hope. So what if I told you that artificial intelligence can do all these same things now, at a speed faster than people can? Without having to sleep, eat, drink, they can run 24/7, all day, every day, and scale out as much as your processing power will allow you. And since AI can be compromised by data and not just a vulnerability, we have a new type of insider threat to worry about. One that mirrors everything that was discussed in this panel earlier, but now it doesn't require vulnerability. So simply by browsing the web, retrieving information, reading a PDF or an email or audio or even a spreadsheet or even a YouTube transcript, we can potentially hijack a system. We can't unplug it. It's the safest way to secure a computer, but we lose all the utility, and the same it holds true for AI. So it's not all bad news. It's not all super scary. We are making advancements. It is progress, and it's been fast. Industry's been moving in lockstep for probably the first time, but we're still having to play catch-up. One of the big things that we focused on as an industry over the last year is to try and make these opaque systems a little bit more transparent, to enable us to understand the idiosyncrasies of a model. And how we've landed on this is by performing things like red teaming. Red teaming in this context is trying to understand how we can prompt inject a model, how we can hide and encapsulate data so that we can compromise the machine, how a model performs under ethical or potential bias constraints, and ensuring that the model is compliant with your organization's threat model for that system. Now, you can say, hey, Owen, can't you just say, put it in the system prompt and say, hey, don't be vulnerable to prompt injection? Funnily enough, sometimes that works, right? And that's the ephemerality of these systems that we're dealing with. They're non-deterministic, meaning the same prompt sent twice can have different results, and often do. So they're not super reliable. Again, the system prompt and the data that was passed in by a user, they're one and the same. They can't distinguish. So prompt injection isn't going away, and OpenAI said this, I think, yesterday. They literally announced, like, we can't solve this problem. So this one's here. But we need to be able to combine different types of security. There's a whole traditional tech stack that we can't forget about. We have application security, we have network security, we have API security and data security, but we need to ensure that these systems work for securing AI. We need to ensure that we're monitoring the inputs and outputs of models. We need to ensure that we're scanning model artifacts for malware and for tampering. And we need to layer all these things up because one solution just isn't going to cut it. Path of least resistance. If I don't need a vulnerability, and all I need to do is send an email, that seems pretty easy to me. So to understand and map the space out and have a common language that we can all speak and interpret, MITRE Atlas released a taxonomy a couple of years ago called Atlas. You're more than likely familiar with ATT&CK, MITRE ATT&CK. I've got 4 minutes, excellent, thank you. MITRE ATT&CK, this is essentially the equivalent that MITRE has produced for understanding the AI threat landscape. OWASP has several great projects, such as the GenAI project. They have the Agentic project, which all define top 10 risks for those particular systems, and I'd encourage you to check them out. And NIST is doing a fantastic job of standardizing these threats and providing really solid definitions here. We're building model signing. We don't currently have the systems to sign models. We sign everything else. We sign network traffic, we sign executable files and file systems, but models no. But models are code. And this is a gap that we have been trying to solve as an industry. The OpenSSF model signing project has, in the last month, released their V1 of their project. I'd encourage you all to check it out if that's something that interests you, especially those of you in regulated environments. We see the concept of software bill of materials expanded to AI to incorporate things like training data, where it came from, more of this metadata around that build. And ultimately, I would love to see these fused with these cryptographic signatures. And industry initiatives which bond together public and private partnerships, such as the Coalition for Secure AI, the Joint Cyber Defense Collaborative, they are leading the way in us working together to solve this problem. So in the efforts of speeding through, my predictions for the future is that agentic AI is the future. I think that the capability that it unlocks is unparalleled. The scale and the ability to roll out new machines and employees will be incredible. And I don't think it's going to replace people. I think it's going to augment them. And that really is what I wanted to talk about today. This report, it's 54 pages. You can scan this QR code here. It's a field guide to securing AI systems. We provide detailed information on how we do these attacks, how we defend them. We provide defense and mitigation recommendations. And most importantly, we provide questions for you to ask your vendors, because this is a really new space. It's difficult to understand. It's difficult to parse. And we want to make sure that you have the right questions and the right tools in your belt. With that, thank you so much. Really appreciate the time. And thank you, Miami. And thank you, HiddenLayer, for the hospitality this weekend. Appreciate it.